Tourism Pathshala, it will transform your dream into reality.
Good afternoon, my dear student. Today we are going to learn the parametric and non-parametric statistics. There are so many important aspects of parametric and non-parametric statistics. Assumption, application, comparative study between parametric and non-parametric statistics. Before that, we have to understand the background, the type of statistics. Statistics basically two types. Can be divided on the basis of function. Statistics can be divided on the basis of function or on the basis of distribution of data. On the basis of function, statistics can be divided into three categories. Number one, descriptive statistics. Number two, correlation statistics. Number three, inferential statistics. First of all, second, on the basis of distribution of data, the statistics can be divided parametric statistics and non-parametric statistics. So parametric and non-parametric statistics are two classifications on the basis of distribution of data. Both are concerned to population or sample. This is very important point. Both are concerned population or sample. Now thing is, what is parametric statistics? Parametric statistics, it is defined to have an assumption of normal distribution. Assumption of normal distribution for its population understanding. This is very important point. We have to remember, in the case of parametric statistics, we have to have a normal distribution. And in the case of non-parametric statistics, which are not based on the assumption of normal distribution of population. Parametric statistics is that populations are normally distributed. In the case of non-parametric statistics, the assumption population is not under the normally distributed. Now we are going to understand the comparative study between on the basis of assumption, parametric and non-parametric study. Assumption or on the condition of the parametrics and non-parametric statistics. Number one, in the case of parametric statistics, data should be normally distributed. Data sample should be normally distributed. In the case of non-parametric statistics, not normally distributed. Next, parametric statistics, normal distribution referred to frequency distribution. Following is a normal curve. This is the normal curve, NPCV curve or normal probability curve, which is infinite in of the both end. And the normal distribution referred to the frequency distribution. Next, in the case of non-parametric statistics, the sample size is very small, generally number of sample 5 or 6. Okay. A normal distribution in parametric statistics, variable must have been measured interval or ratio scale. And here non-parametric statistics can be expressed in the form of rank or in the shape of sign, positive sign or negative sign, or classification like good, bad. We use the non-parametric statistics. So in the case of rank and classification, we use non-parametric statistics. And in the case of the variable must have measures interval and ratio scale in the parametric statistics. In parametric statistics, observation must be independent and population must have the same variance, and in the special cases the population must have the same variance. In the special cases, must have a known ratio of variance. This we call the homoscedasticity. In the case of non-parametric statistics, variables are expressed in nominal form. These are the comparative study or based on the assumption of parametric and non-parametric statistics. Our next important topic, the key comparison table. So from this assumption, what we have got, in the case of assumption parametric statistics, I have already told you, normally distribution, specific distribution, usually the normal distribution, or Gaussian distribution. Non-parametric statistics make no assumption about the underlying distribution. In the case of central tendency parametric statistics, we use the mean. And in the case of central tendency, in the non-parametric statistics, we use the median. Data type. Parametric statistics data type, generally interval and ratio data or continuous data. And non-parametric statistics, we use the nominal or ordinal data, basically categorical or rank basis. Sample size. In the case of parametric statistics, sample size typically require larger sample, nearly more than 30. Sample size more than 30. Sample size large. And non-parametric statistics affects a small sample size. Sample size should be 4, 5 or 6. So within 5 to 6. In the case of statistical power, parametric statistics, high power. Statistical power is high, means more likely to find significant effect if it exists. The case of non-parametric statistics, statistical power is low, require larger effect or sample to find significance. Now this is the point, we have to understand the statistical power. What do you mean by statistical power? In simple term, statistical power is a probability. What is statistical power? Is a probability that a study will detect an effect, likely difference between the group when one actually exists. In simple terms, statistical power is the probability that study will detect an effect. In our study has high power, we are likely to find statistical significance. Result if the phenomena we are testing in real. In the case of lower power, lower statistical power, we might miss the real effect, leading to the false negative. The false negative also called the type 2 error. So what is type 2 error? It is a statistical term used to describe the error that results when null hypothesis that is actually false. Null hypothesis when actually false is not rejected by an investigator or researcher. So that is called type 2 error. When null hypothesis false, we accept the null hypothesis, that is called type 2 error. So in the power of low, the false negative or type 2 error can be arise. In the case of mathematical definition, the mathematically power is defined as, power can be defined like this, power equal to 1 minus beta. The beta means beta is the probability of making up type 2 error. When beta is the probability of type 2 error, in most significant, in the case of most scientific research, the standard goal for power is 80% or higher. This means we have an 80% chance of detecting an effect and 20% chance of missing it. The mathematically expression power equal to 1 minus beta. And beta is probability of making a type 2 error. So we can understand the statistical power. Now move on the next topic, the common test equivalent, parametric and non-parametric test. If data fail to assumption for parametric statistics, like we test for normality, we would use the non-parametric counterpart. So this is our goal or cases. Then we comparative study the parametric and non-parametric equivalent use. Compare two independent group. When we are going to compare two independent group, we use the parametric. In the case of parametric statistics, independent sample t-test. And in non-parametric statistics, we use Mann-Whitney U-test. Compare independent sample more than two group. Compare independent sample two group. Parametric test, we use the independent sample t-test, and equivalent non-parametric Mann-Whitney U-test. Compare independent more than two group. In the case of parametric statistics, a test, we use one-way ANOVA, means analysis of variance. Compare independent sample more than two group. Non-parametric test, we use Kruskal-Wallis test. In the case of compare dependent or related sample to group, parametric test, we use Pierce sample t-test. Counterpart, non-parametric, we use Wilcoxon sign rank test. In the case of compare dependent sample, means related sample more than two group, we use the parametric. In the case of parametric statistic, we use one-way repeated ANOVA. And counterpart, non-parametric statistics, Friedman's ANOVA. In the case of correlation, parametric test, we use the Pearson product moment correlation. Counterpart, non-parametric test, we use the Spearman RHO rank order. And in the case of central tendency, parametric tests are mean, counterpart in the case of central tendency, median and mode. This chart, this comparative chart is very important for UGC NET JRF student. UGC generally provide the question from this area. So my dear student, you keep this chart minutely, you follow this chart, try to remember this chart minutely. This is a very important area. Our next topic is when to use parametric and non-parametric statistics. When to use parametric test, when data is continuous and follows the bell curve, means normal distribution curve. When we have large enough sample size, usually greater than 30, equal to or greater than 30, we use parametric statistics. We need more power to detect subtle differences, we use parametric statistics. When we use or choose non-parametric test, when data is ranked first, second, third or categorical, we choose non-parametric statistics. When data is heavily skewed or contains significant outlier, the skewed distribution, scattered, then we use non-parametric. When sample size is very small, making it impossible to verify the distribution, in that case we use non-parametric test. Parametric statistics used for data analysis. What are the uses of parametric statistics? T-test, F-test and R-test are used for the parametric statistics. Non-parametric statistics test used for inference, to draw the inference or conclusion. In the case of chi-square test, median test, Mann-Whitney U-test, these are the non-parametric statistics. My dear student, try to remember T-test, F-test and R-test is the parametric statistics. Chi-square test, median test, Mann-Whitney U-test, these are the non-parametric statistics. Some non-parametric statistics for related sample, maybe sign test or Wilcoxon matched pair sign rank test. So these are the use of parametric and non-parametric statistics. Now the final part, advantages and disadvantages of non-parametric statistical test. Advantages: if the sample size is very small, then may be no alternative except to use non-parametric statistical test. The sample size is small, we use the non-parametric statistics. Non-parametric tests typically make fewer assumptions about the data may be relevant to particular situation. Number third, the hypothesis tested by non-parametric test may be more appropriate for research investigation. The hypothesis test may be non-parametric test may be more appropriate for research investigation. Next, non-parametric statistical tests are available to analyze data which are inherently in rank. Data in rank form, we generally use non-parametric statistics. Non-parametric methods are available to treat data which is simply classification or categorical. So these are the advantages of non-parametric statistics. What are the disadvantages? If all the assumptions of parametric statistical model are in fact made in the data and the research hypothesis could be tested with parametric test, when non-parametric statistical tests are wasteful. So if all the assumptions of a parametric statistical model are in fact made in the data. Another objection to non-parametric statistical test has to do with the convenience. This is a very important part. The case of convenience, table necessary to important non-parametric statistic test are scattered widely, appear in the different format. So the convenience of the data is another important part. So what we have learned through these classes: advantage, disadvantage of non-parametric statistics test. We also learn the uses of parametric test and uses of non-parametric test. We also compare the statistical test, parametric test and non-parametric test, comparison different situation and circumstance. We understand the statistical power. Next, we also learn the comparative study between parametric test and non-parametric test based on the different features, and we also learn the assumption of parametric and non-parametric statistics. So these are the important area of our parametric and non-parametric statistics. Both are very important for our UGC NET and JRF student. So you try to remember this chart in this way. If you have any queries, any doubt, any question, you send the message through my WhatsApp. So keep touch this channel, or any queries you may contact with me.